Assalamu alaikum. Hello students. Today we have to discuss Gauss's law in differential form. For that purpose, first of all, we have to write Gauss's law in integral form. What was integral form of Gauss's law? That was flux through any closed surface is equal to Q divided by epsilon naught. And according to definition of flux, this phi will be equal to E dot ds is equal to Q by epsilon naught. Okay, so this is surface integral here. This is surface integral here. Now let us relate this surface integral to volume integral, and for that purpose we use Gauss's divergence theorem. So according to Gauss's divergence theorem, the surface integral of any vector E, the surface integral of any vector E equal to volume integral of divergence of that vector, equals to volume integral of divergence of that vector. Okay, so by using equation number 1 and equation number 2, we can write by 1 and 2, we can write Q over epsilon naught is equal to integral of divergence of vector E, and in the next step it becomes Q is equal to epsilon naught del dot E into dV. Here this epsilon naught is constant, that's why can be shifted into the integral. Okay, so this is equation number 3. Now by definition of volume charge density rho, by definition of volume charge density rho will be equal to charge contained per unit volume. So by separating value of Q, we get here rho into V, and if we want to write this expression into the integral form, it becomes rho into dV inside the integral. So this Q can be replaced by that expression. So if I replace this Q by that expression, it becomes rho into dV is equal to epsilon naught del dot E into dV. Now clearly both of these two integrals are equal with same variable. Both of them have same variable V. That's why the integrands, that means the expression inside the expressions inside the integral will also be same. So this rho will be equal to epsilon naught into del dot E. So let me write that. Now it becomes, okay, now it becomes rho is equal to epsilon naught del dot E, and in the next step it becomes finally del dot E is equal to rho by epsilon naught, and this is differential form of Gauss's law because it contains derivatives, it contains partial derivatives. How? Because this del dot E can be written as, you are well aware, it can be written as partial by partial x Ex plus partial by partial y Ey plus partial by partial z Ez, and all of this is equal to rho by epsilon naught. So that's why this contain of Gauss's law contains derivative in it. That's why it is called differential form of Gauss's law, while the original form that you have been studying from lower grades, this form, this is called integral form of Gauss's law because it contains integration sign in it. Hope it's clear. In the next lecture we will see our next problem. I think that is problem number 2.9. Goodbye.